Okay. So this is going to start our reactions lesson. This is just an introduction to our full chemical reactions. These are the signs of a chemical reaction. I think we reviewed these right before the break. So heat, light, formation of a gas, formation of a precipitate, and color change. If you feel like you need to write these down, go ahead and do that. We've talked about it a lot. If you think you got it, then you might not have to put it in your notes. Make sure you jot down the law of conservation of mass, and remember that the definition of that is that mass is neither created or destroyed. Okay, it all has to stay the same. That's where balancing equation comes in. And if you look down here, if you start with 4 hydrogens, you got to end with 4, and clearly there are 4 over here. They've just rearranged. They went from being just 4 H's into combining to make 2 water molecules, CH2O. And then also the mass has to be the same. So here's our arrow, right? So these are the reactants and these are the products. To the left of the arrow, the mass has to add up to be the same as to the right of the arrow. So 32 plus 4 is 36 grams total over here. To the right of the arrow, there's also 36 grams. So the mass has to be equal on either side because it cannot be destroyed. Okay? Remember, in a chemical reaction, to the left of the arrow is called the reactants. I'll refer to them all the time by that, so make sure you remember that's to the left. And then to the right, those are the products. That is what is formed during the reaction. Take a minute and write all of these down. You're going to want these in your notes to refer to, especially on your quiz. You need to be able to take the arrow and write words for it, produces, forms. On this one, I also want you to add yields, okay? So just comma and add the word yields because you'll also see that describing this arrow. For the plus sign, you can say plus. You can use the word and to describe this. I want you to add a comma, and at the end, I want you to add reacts with, okay? So sometimes they'll use the term reacts with that stands for the arrow. Now, keep in mind, you're only going to be able to use the term reacts with on the reactant side, not the product side, but I do want you to add that here at the end, reacts with. All right, and then take a minute and write these other ones down. The little S is for solid, L is for liquid, G is for gas, AQ is for aqueous, and then here's a description of what aqueous means. It's just that solid is dissolved in water. So for instance, if you had salt, NaCl, and it had an AQ after it, that would mean that the salt was dissolved in water, okay? The little triangle above the arrow means that the reactants were heated to drive that reaction. So this triangle above just a normal arrow means that they were heated, but I would highly suggest writing all of this down in your notes. Okay. Also, notes that you will definitely need are these. So whenever you're writing equations, you're going to have to identify the substances involved. Okay. For instance, here we have hydrogen, we have oxygen, and we have water, H2O. This is hydrogen gas. That's what the G means, right? This is oxygen gas, and then this is water gas, which would be a vapor, correct? It's not liquid water, it's gas. The big numbers in front are called coefficients, all right? It tells you how many you have. So if I have this hydrogen molecule here, I actually have 2 hydrogen molecules, okay? I have 1 oxygen molecule and I have 2 water molecules. So the big number in front of the formulas is called the coefficient, and it tells you how many you have, all right? Remember the diatomic elements. Whenever this slideshow is over, I will remind you of those. I'll pull up the periodic table and I will go over those again. All right, so this is an example problem. Absolutely write this down. You're going to want to refer back to this on Friday, okay? So you're either going to be given a sentence like this and have to write the reaction, or you're going to be given a reaction and have to write the sentence, okay? You got to go both ways. So this is the first of the 2 ways. Here's our sentence, okay? And you have to write the reaction, all right? So I have 2 atoms of aluminum. So this is how you would write that, okay? 2 atoms of aluminum. Aluminum is Al, right? And it doesn't tell us a state. If it doesn't tell you specifically what state it's in, then just assume it's in its most natural state. So aluminum is a metal. That means it would be a solid. Okay, so they just put an S after it. All right, here's reacts with. Okay, we talked about a couple of slides before that reacts with stands for the plus sign. Okay, so that's all that would go there is the plus sign. I know the 3 popped up, but the plus is for reacts with. Okay, next is 3 units of aqueous copper 2 chloride. So here we are. You've got to be able to write your formulas, okay? So there's the 3 because there are 3 units. The 3, it's referring to the coefficient. Now, you have to be able to write copper 2 chloride here for the reaction. So copper is Cu, chloride is Cl. Copper has a 2 charge. I know that because of these Roman numerals. Chloride has a 1 charge. Okay, you'll have to refer to your periodic table to look at those charges. So the formula is CuCl2 because it's ionic and they switch charges. So copper's 2 charge went here to chlorine, and chlorine's 1 went to copper. All right, that's aqueous copper 2 chloride, so you're going to need to put an AQ after it. Okay, then we have to produce. Remember, to produce is the arrow. I know the 3 popped up, but really shouldn't. It should just be the arrow. To produce stands for this arrow right here. All right, 3 atoms of copper. So there's my 3, right? Because I have 3 atoms of copper. Copper is Cu. It's just a single copper. There's no formula right there. And they don't tell you what state. So again, like we did with aluminum, you're going to assume it's in its most natural state, which is solid. All right. And, don't skip and. And is your plus, remember. And stands for plus, so that's what we put there. Don't skip it like I almost did. All right, 2 units of aqueous aluminum chloride. So I have a 2. Aluminum chloride, remember where these numbers are coming from. This is an ionic compound, so chlorine has a 1 charge, which it gives to aluminum, and aluminum has a +3 charge, which it gives to chlorine, and it looks like that. That's where those numbers are coming from. All right, and it's aqueous aluminum chloride, so put that AQ after it there. Okay, so that's taking the sentence and writing out the equation. You absolutely should write this in your notes. It's an example, okay? Now, in order to do the other one, in order to be able to write out that sentence that you just seen, you need to be able to describe these formulas the correct way. For instance, if it's an individual atom, like a while ago we had copper all by itself, Cu, we call that an atom, okay? We also had aluminum all by itself. We would call that an atom. It's a single element, okay? If it's covalent, remember how to tell if it's covalent. 2 nonmetals bonded together is covalent. If that's the case, we're going to call it a molecule. If it's ionic, which means a metal bonded to a nonmetal, remember that, then we're going to call it a unit. All right? So down here are some examples of how to use these describers here, okay? So if I was wanting to write a sentence to describe this right here, okay, I would say that I had 3. CO2 is a molecule because it's covalent. Carbon is a nonmetal, and so is oxygen. That's 2 nonmetals bonded together. It makes it covalent. We're going to call it a molecule. So I would write 3 molecules of carbon dioxide. You got to remember how to write your names, guys, okay? So carbon dioxide, because the 2 is di. Remember, with covalent compounds, we use these prefixes. Di, tri, tetra, all of those. All right, for the next one, we only have magnesium. It's all by itself. It's a single element. That means it's going to refer to this first bullet here, and we're going to call it an atom. Okay, so we're going to say 2 atoms of magnesium. You just look up the name for Mg. All right, last one. Magnesium is a metal. Oxygen is a nonmetal. That means this is an ionic substance. Okay, since it's ionic, we're going to call it a unit. So you would describe it this way. 4 units of and MgO would be magnesium oxide. 4 units of magnesium oxide. Change that second to ide. All right. So with that, you have to be able to take an equation like this and then write the sentence for it. Okay. So let's just get started. This is definitely the harder of the two, I think. Trying not to leave anything out, I think, is the hardest part. So for this first one, I have 1 because there's nothing in front, no coefficient. That stands for 1 always, right? In chemistry, because there's nothing there. So we have 1 atom of solid zinc. Okay, ZN is zinc. I'm calling it an atom because it's a single element. We talked about that in the previous slide. Okay, so 1 atom of solid zinc. Okay, remember you've got some options for plus. You can use and, plus, or reacts with. It doesn't matter which one you pick. Okay, they would all be correct. So we're just going to say reacts with here. Remember, if you do use reacts with, you have to use it on this side. But if you had written plus or and, yours would be perfectly fine also. Okay, so now we're here and we have 2. This is 2 nonmetals. Okay, so we're going to call acid. This is an acid, starts with an H, right? Acids are molecules. Okay, so we have 2 molecules. And now you have to remember your acid naming rules. Okay, it starts with an H, so it's an acid. It has a single element after it, so we use hydro. You definitely, when you take this quiz, you may want to use your naming notes, and you can use those. Okay, so that would be 2 molecules of aqueous hydrochloric acid. All right, absolutely refer to your acid naming rules if you need to, and have those on Friday as well. You've got options for the arrow. Here they use to produce, but you could have used yields. Okay, that was one of our options. So, and yours would have been correct also. But here they're just going to use to produce. Okay, nothing in front, so it's 1. Zinc is a metal bonded with a nonmetal, so that's ionic. We're going to call it a unit. So 1 unit of aqueous zinc chloride. Okay. 1 unit of aqueous zinc chloride. We have our plus here. Use what you want. They used and, okay, so I know it put the rest of it there, but just focusing here for this plus, okay, they used and. You can use and or plus. They both would have worked there. And then for this last one, there's nothing in front, so 1 molecule of hydrogen gas. Okay, because that's hydrogen. Now, you may be wondering why they called it a molecule, even though it was a single element. Hydrogen is diatomic. Okay, it's one of those 7 diatomic elements that we talked about before. And all that means is that when it's alone like this, like hydrogen's by itself, hydrogen gas, it occurs bonded to itself naturally. So we always put this little 2 with those 7 diatomic elements. And that also makes them molecules instead of single atoms. So that's why that one was described as a molecule instead of an atom. All right. Okay. And what I want to do real quick before we end this is show you the 7 diatomic elements again. So remember, it was hydrogen. Oops, let me get my brush here. That's fine. Okay, it was hydrogen. That was one of them. And then the other ones, they actually make a 7 over here. So nitrogen, oxygen, fluorine, and then chlorine, bromine, iodine. They make a 7, okay? And I'm just going to go ahead and circle them so that we're sure on which ones they are. So that means that all these 7 elements, anytime you write them alone, so if I was going to write nitrogen, sorry, I don't have my pen, by itself, I would always need to put that little 2 by it, okay? Any other one, so say aluminum, I needed to write aluminum by itself. I would just write Al, okay? No 2 because it's not diatomic. N2, O2, F2, all of them. And I know my writing's bad. I don't have my pen attached, so I'm just doing it with the mouse. But you get the idea, okay? Any of these right here, 1, 2, 3, 4, 5, 6, 7, that you write by themselves, put that little 2 after it, okay? Because they're diatomic. Any other element you write by itself, it does not need the little 2. Also, these also don't need that 2 if they're bonded to something. You would use their charge, right? So nitrogen has a -3 charge. These guys have a -2, and these guys have a -1. That does not change, okay? The only time these little 2's go here is when they are written alone, okay? Not bonded to something. When they're bonded to something, continue to use these charges that you've always used. All right.